All right, so 1.2 is linear equations and rational equations. And since I've written out some of this stuff, if I were to move too fast or whatever the case may be, always feel free to unmute, ask me to slow down, or could you go back, whatever the case may be. Always feel free to let me know. So linear equations and rational equations. So main thing we're talking about is solving these equations. An equation is just a statement that two algebraic expressions are equal. So if we're looking at this first example right here, x plus 5 equals 7, that's an example of an equation saying x plus 5 is equal to 7. Now, a solution is going to be value or values. It is possible to have more than one solution that will make your statement true, your equation true. And in this case, x is equal to 2 is the solution for this equation. So in other words, the question you should be asking yourself, and that's what I wrote down here. The question you should ask yourself is, when is x plus 5 equal to 7? And the answer is when x is equal to 2. So whenever you're talking about solving an equation, you want to know, when is this statement true? And your solutions will be the answer to that question. And remember, you always can plug in whatever your solution is back into your equation for x to check to see if it's correct. All right. Write that all over. All right, questions, any questions? All right, so we'll be solving, and this section doesn't really go this far back. I'm just trying to make sure everybody's cool with solving equations. But if you look at how 1.2, or really most of chapter 1, they really set it up more so as a review, not necessarily as a background or introducing it. So I'm just trying to go back, make sure everybody's with us before we go all the way in. Opposite operations, we'll be solving by what I call opposite operations. That's when addition and subtraction are opposite of each other. In other words, the operations that undo what the other one does. Same thing with multiplication and division. They undo what the other one does. So if you're talking about solving, your goal is to get your variable by itself. So if I have x plus 5 equals 7, going back to that equation, we already know the solution is 2, but how do you get there? First thing you would do is undo what's being done to your variable. You want to get your variable by itself. Since this is x plus 5, that means we're going to subtract 5 from both sides of the equation. And what I mean by both sides is that your equal sign will separate left and right side of your equation. Whatever you do to the left side of your equal sign, you have to do to the right side as well in order to keep your equivalency. So positive 5 and negative 5 will cancel on the left, leaving you with just x. 7 minus 5 is 2. And so that's how you get your solution. All right, so let's just run through the other few. Make sure we're all right. So here we have y minus 10 equal to 15. So to solve for y, I will add 10 to both sides of the equation. 10 cancels on the left, leaving you with y. And then on the right, 15 plus 10 is 25. The next one, 5a equal to 13. So 5a, that's 5 times a. So in order to do opposite operation, we use division. So 5 divided by 5 is 1. In other words, they cancel for us. And then 13 over 5 would be on the right. So notice that we left it as 13 over 5. It is okay to leave it in a fractional form. We don't have to necessarily convert it to a decimal or a mixed number unless specifically asked. Now, you are expected to reduce fractions. Remember, converting it to an improper fraction is not necessarily the same thing as reducing it. Right here, this is considered reducing your fraction. If you have 4 over 6, you see that 4 and 6 have 2 in common, so you can reduce both numbers by 2 and be left with 2/3. That's reducing your fraction, and that is what they are expecting you to do. 13 over 5, you don't have to do anything with that because you cannot reduce it any further. Now, the last one of our simple equations, we have x over 9 equal to 11. X over 9, x divided by 9, so we'll multiply both sides by 9. 9's cancel on the left, leaving you with just x. 11 times 9 is 99. So before we add more to it, any questions on what we've done up to this point?
I'm sorry, can I see the very beginning of where we started? I have everything else, just the very beginning.
Right here? Yep.
Okay, thank you.
Mm-hmm. Okay.
And Professor,
Yep.
so these are the same notes that you went over last semester. So if anybody had any more questions in terms of like notes that they maybe missed, then they could potentially go back to those like videos and see them for themselves.
Absolutely.
All right. Is your YouTube channel, is it just your name or do you have a specific name for it?
I think it's Professor T's notes. I think that's what it was. I can look
Okay.
real quick. Help me on 1 second. It's taking a while to pop up. Yep, Professor T's math notes. And it has the pi symbol as the emblem.
Awesome. Thank you, Professor.
Not a problem. And so with that being said, for anybody, if you have any questions, like I did statistics, I have stats up there, PreCalc 2 up there, developmental courses, let's say if you're having trouble remembering your signs or anything, I've got a lot of videos up there. So feel free to go through them if you like how I teach or whatever, and you got me help with other stuff, feel free to go check them out. All right, so we have 2x plus 1 equal to 17. So this one involves more than just one operation. So what you would like to do is, once again, your goal is to get x by itself. So you want to remove the things that are furthest away from x first. That would be the best way to look at it. So in other words, I have 2 times x plus 1 that's on this left side of our equal sign. So the first move is to actually move that 1. Now I could divide by 2. But if I do that, I need to divide both sides by 2. Now we're making more of a fraction for ourselves, more of a complex equation for ourselves. And we don't want to do that if we don't have to. So we would subtract 1 from both sides. 1's cancel. That leaves me with 2x equal to 16. And that's why I drew this arrow over here. Take it up there. I was trying to save on space. And then 2x equal to 16. I can go ahead and divide both sides by 2. 2's cancel. And that leaves me with x equal to 8 as our solution. So we subtracted 1, then divided by 2. And remember, we did it to both sides. Whatever you do to one side, you have to do to the other in order to keep your equivalency. All right, any question on that one before we go to the next one? All right, so the next one, and try to make this evident, this is a whole nother problem. I don't know if that does it. But anyway, we have 2 times the quantity of x plus 3, x minus 3, minus 17 equal to 13 minus 3 times x plus 2. First thing we're going to do is distribute that 2. And then here, we're not going to just distribute 3, but we will distribute negative 3 into your equation. All right. So what will happen is the distribution of 2 will be 2x minus 6 minus 17. And we have 13 minus 3x minus 6. All right. So now we have this quantity over here and this quantity over here. What I would do is simplify as much as possible on each side first before I start to move anything across that equal sign. So notice that negative 6 and negative 17 will give me negative 23. And then on the right side, I have 13 and negative 6, which would be a positive 7. And so that's where we are now. 2x minus 23 equal to 7 minus 3x. And don't forget, negative 3x plus 7 is the same thing. As long as the 7 is positive, the 3x is negative, you still have the same quantity. Any questions so far? All right, so the next thing we would do is now we're looking to move all of our terms with x to one side, all of our terms without x to the other. So it doesn't matter which term you move first. Notice we have 2x minus 23, 7 minus 3x. We have 4 different terms. It does not matter which one you move first. It does not matter which side you move it to. As long as you stay correct with your mathematics, you still get the same answer when everything's said and done. So what I'm going to do is add 3x to both sides. On that right side, 3x minus 3x will cancel. And that will leave me with 2x plus 3x, which is 5x minus 23 equal to 7. All right, so now we will add 23. So negative 23 and positive 3 will cancel, leaving me with 5x equal to 30. And then to finish it off, divide both sides by 5. And x is equal to 6. Any questions? All right. Scroll up, everybody's good, everybody's good. All right, so for the next one, we have 5x minus the quantity of 2x minus 10 equal to 35. All right, so first thing we're going to do here is we want to remove that parentheses. We have 2x, we have that x inside of the parentheses, so we need access to the x. So we need to remove what's in front of the x, or what's holding the parentheses there, and that is this minus sign. So we'll distribute the minus sign to each term. That will give us 5x minus 2x plus 10 equal to 35. All right, all it does is change the signs of each term that's inside of the parentheses. Then from there, we can combine our like terms. We have 5x minus 2x, and that gives us this 3x right here. So that gives us 3x plus 10 equal to 35. Now we can minus 10 from both sides. Remember, your goal is always to get your variable by itself. What we have now is 3x equal to 25. And then to finally solve for x, we'll divide both sides by 3. 3's cancel, leaving you x equal to 25 over 3. All right. Any questions? Very good. All right. Next one. We have x plus 2 over 4 minus x minus 1 over 3 equal to 2. So the way we go about solving this one is that we want to do what we call clear out the fractions. Now you can work this out with the fractions involved. Most people don't want to do that, and I wouldn't say it is the easiest route to go. So the best way to go is to clear out your fractions. The first step in clearing out your fraction is to find the LCD. Don't forget your LCD is the smallest number that each denominator can divide into evenly. I can work that a little better. So it is the number that each denominator can divide into evenly. So in this case, that's going to be 12. We have 4 and 3. So 12 would be the smallest number that both 4 and 3 can divide into evenly. Now, by some chance, you pick a number that's larger than 12. As long as 4 and 3 can divide into it evenly, you still will be okay as far as your process is concerned. Just have a larger number to deal with. Eventually, you'll still get the same answer. But the main thing is that 4 and 3 has to be able to divide into it evenly. All right. So then step 2 is to multiply each numerator by the LCD. Notice I said each numerator. We're not doing top and bottom. We're multiplying across the equation. We're multiplying each numerator by the LCD. So that's what I did here. And make sure I got plus 2 right. So that's 12 times the quantity of x plus 2 over 4 minus 12 times the quantity of x minus 1 over 3 equal to 12 times 2. And don't forget that even if it doesn't have a denominator, you still have to multiply it times the LCD. So a lot of times what people will do is they'll forget the 2 that's over there by itself. But you have to multiply everything by 12 or multiply everything by the LCD, or you will be changing the value of the equation. All right. Next step is to simplify. And so what we mean by that is that 4 is going to divide into 12 and leave you with 3. 3 will divide into 12 and leave you with 4. And that will leave you with 3 times x plus 2 minus 4 times x minus 1 equal to 12. Then from there, we will go ahead and solve. The fractions are gone completely. And we can go ahead and do so by starting off with distributing. Distribute at 3, distribute negative 4. And you have 3x plus 6 minus 4x plus 4 equal to 24. Combine your like terms. It's 3x minus 4x, positive 6, and a positive 4. So 3x minus 4x is negative x. 6 plus 4 is 10, and that's equal to 24. Next, we can subtract 10. And so we're left with negative x equal to 14. And to finish it off, I can take my negative, because remember you're solving for x, not for negative x. Take my negative over to the right, and x is equal to negative 14. All right, questions on that process before we go to the next one? All right. So next we get into rational equations. Hold on one second, let me see something. Yeah. Next we get into rational equations. So basically, a rational expression is just a fraction. And so this, when we talk about rational equations, for the most part, that means we're going to have x, our variable, in our denominator. So we're going to take on the same thought process that we did here when it came to clearing out our fractions. You know, we're going to find our LCD, multiply each numerator by the LCD, simplify and then solve. So let me erase some of this stuff. I'll rewrite it. All right, so our LCD here, we're looking at x, 5, and 2x. Remember, we're talking about the smallest expression that x, 5, and 2x can divide into evenly, and that's going to be 10x. Got 5 times 2, which is 10, and then that 1x will be the expression that all three can divide into evenly. And then we're going to multiply each numerator by that 10x. So we got 10x times 1 over x, 10x times 1 over 5, 10x times 3 over 2x. So we're talking about steps. This was our first step. This was our second step. Third step is to simplify, which is what we're about to do next. So x and x will cancel. 5 divides into 10 leaves you with 2. X and x will cancel, and then also 2 divides into 10 will leave you with 5. So we're talking about our most simplified expression now. 10 times 1, which is 10, equal to 2x plus 15. So this is our most simplified expression after we multiply each term by the LCD. So before we go any further, make sure we're okay.
My screen froze. Can you like scroll up, please? I didn't get most of it.
You talking about the last problem, or?
Like I was trying to get the word, and it was froze for a long time. I was left at where you was like writing down find the LCD.
Okay, so this is what we'll do. I'll double back. Let me finish this problem.
Okay, I'm sorry.
Oh no, you're fine. You're fine. So I'll double back, or and just leave space in your notes, and then I'll make sure you get that. All right. So we're looking at 10 equal to 2x plus 15. Now we can solve this the way we did all the rest of the problems. Subtract 15 from both sides. 15 cancels on the right, leaving you with 2x. 10 minus 15 is negative 5. So 2x equal to -5. You divide both sides by 2. 2's cancel, and that leaves you with x equal to -5/2.
So, Professor, I have a quick
Yep.
question about that. So how come it ended up being x equals -5/2 instead of x equals -5/2?
Oh,
If that
that's the
makes
same
sense.
thing.
Okay, so so you could have written it out as x equals -5/2 or x equals -5/2.
Mm-hmm. Yep.
Okay.
Same thing. Or even if you wanted to write +5 over -2, those are the same thing. It's just that this negative normally is up top.
Understood. All right.
Yep.
Thank you, Professor.
Not a problem. Yep. As long as you don't have -5 over -2, then that would be different because negative over negative would be positive. So, yep. All right. Any questions before we look at the next one? Everybody good?
Could you go up to the original problem, please?
Now, when you say original problem, this was the whole problem. Now, if you go back here, you're
Yes,
talking
that's
about this one.
no. I was talking about like the beginning. Yeah,
Yeah,
right.
that's the beginning of that one.
Okay, thank you.
Not a problem. All right, let's look at this next one. And let me erase some stuff. All right, so we have x over x minus 3 equal to 3 over x minus 3 plus 9. So our LCD is going to be x minus 3. That's the only denominator that we have. So we don't have to try to figure out anything else. X minus 3 is the least common denominator. So to get rid of that, we're going to multiply that x minus 3 to each numerator. And that's what I did down here at this bottom line. X minus 3 times x over x minus 3. Then we have x minus 3 times 3 over x minus 3. And then we have x minus 3 times 9. Let me write that better. All right. So the next move is for, oh, did somebody say something? Did somebody unmute? Okay, thought I heard something. So the next move is to cancel out the x minus 3, quantity of x minus 3. And then what you are left with is just x on the left, 3, and then here we'll distribute 9. So it'll be 9x minus 27. We can combine our like terms. 3 and negative 27 will give us negative 24. All right, so we have x equal to 9x minus 24. We need to get all of our x terms, or all of our terms with x, to one side. So we'll minus 9x from both sides of our equation. That will leave me with negative 8x equal to negative 24.
Can I ask a question, please?
Sure.
So the 3 x equals 3 plus 9x, is that when aren't you supposed to like subtract that that 3, make it a -3, and then it's gonna go like under the -27, which does that
Oh,
not make it -30?
that's if you had the equal sign right here. So notice we had the plus sign right here and the equal sign right here. Both of these were on the same side of the equation, so you can just combine them as they are.
Oh, okay.
Yep.
Thank
So
you.
now, yeah, no problem. So now, if you want, that's a great question. Now, if you want to move the 3 to the other side of your equal sign, that's when you would subtract 3 from both sides.
Got you.
Mhm.
Okay.
All right. And everybody else good? So once again, just, since they both were on the same side of the equal sign, we could just add them together as they were. We had a +3 and a -27, and that gave us a -24. And be careful with that. That was a great question because a lot of people make that mistake. They get in their flow, you know, and sometimes these symbols start to run together. So that was a great question to point out. Questions before we go to the next step? Pretty good. All right, so now we can finish off the solving by dividing both sides by -8. 8 and -8's canceled, and that leaves us with x equal to 3. All right, so remember I mentioned that if you ever want to check your solution, you're going to plug it into your original equation. You don't necessarily have to check every single time. If you did everything correct, then you should get the right answer. There will be situations where you have to check. Even if you've done everything correctly, you still could have an answer that's not a legitimate solution. We haven't gotten there yet. But here, you want to at least check your denominators. If you don't feel like checking the whole equation, you still have to at least check your denominators. And what do I mean by that? I need to take this x equal to 3, plug it into, at least check these denominators. Notice what happens when we plug it into the equation. I got 3 over 3 minus 3 equal to 3 over 3 minus 3 plus 9. I get 3 minus 3 in my denominator, which gives me 0 in my denominator. So even if this plus 9 wasn't here and I had 3 over 0 equal to 3 over 0, that's still bad because, like I mentioned, 0 in your denominator is undefined. There will always be a situation that you do not want to have. So here goes our conclusions with that. Since x equals 3 produces 0 in the denominator, we cannot use it. That means x equal to 3 is extraneous. That's what we call an extraneous solution. And since x equal to 3 is our only option for a solution, this means that the answer is no solution. And so what I mean by that third statement is that, let's say if we had two solutions, x equal to 3 and x equal to 5. If x equal to 3 ended up being extraneous, I still can use x equal to 5. So my answer wouldn't be no solution. It would just be the solution that's left. But x equal to 3 was our only solution in this case. That one didn't work for us. So that means our answer is no solution. All right. Questions? Any questions? All right. Any problems before I go to the next one? Sorry, I see one of your classmates that sent me an email, so I'm checking that out. Scroll up. Everybody okay? Everybody okay? All right. Let's look at the next one. All right, so here we have 3 over x plus 6 plus 1 over x minus 2 equal to 4 over x squared plus 4x minus 12. So we need our LCD, and this is going to lean on your factoring skills a little bit. So we have x plus 6, x minus 2, and our third denominator, when you factor it out, x squared plus 4x minus 12 is going to be x plus 2 times x minus 2 as well. X plus 6 times x minus 2. So when we look at our LCD, your LCD needs to be a combination of each numerator that you see, and without any repeated quantities. So you have x plus 6, x minus 2, and then that third denominator is a combination of the two. So that's what we would use as our LCD, x plus 6 or times x minus 2. And once we go to the next step, remember, we're going to follow the same procedure. First step is to find the LCD. In other words, find the simplest expression that each denominator can divide into evenly. Then we're going to multiply each numerator by that LCD and then reduce. All right, so this is the next step. Multiply each numerator by the LCD, which is x plus 6 times x minus 2. All right, so now notice what we can do is x plus 6 will cancel in the first one, x minus 2 cancels in that second one, and then in the third one I had to come down here because I ran out of room on the right. But x plus 6 will cancel and x minus 2 cancels.
Can I ask a quick question, sir?
Yep.
Hey, so on the LCD then in this case is the x minus 6, or excuse me, the x plus 6 and the x minus 2, because it is basically the same thing as that x squared reduced, correct?
Yes. Now, let's say if this first one had another quantity attached to it, then that means x plus 5 need to be a part of that LCD as well. Oh, not down, not here. Sorry, over here. You know, so each quantity that you see needs to be represented in your LCD.
Gotcha. So basically, because I mean the x squared kind of got a little confusing, but because it just wasn't reduced down. If we reduce it down, then there's no reason to be worrying about it.
Right. Exactly.
Right. Don't push the panic button.
Right. So now, once again, and that's what I was mentioning about, there will be certain things in this chapter of chapter 1 that they are expecting you to come in with. So if you're having issues with factoring or you forgot your factoring skills, because that's what we did with that trinomial, you know, we factored it down to those, you know, to x plus 6, x minus 2. And I'm not saying this to you specifically. I'm talking about to everybody, because that's a great point you just brought up. If you having trouble with factoring or forgot some of your factoring practices, always shoot me an email. I have videos on that, or we can just talk about it. Depends on what you want. But that YouTube channel, I went over a lot because I have classes from Norfolk State. You know, like I said, developmental classes at TCC, other schools that I've taught at, and so we talk about pretty much everything in those videos. So I have a video for pretty much anything you may come across. So I can shoot you some of those links, or if we need to set up a Zoom session outside of class to revisit some old topics, then we can do that as well. But there may be some things that I run across that I'm thinking, okay, you're supposed to know that, because remember, this is pre-calc, that's algebra. So I'm glad he brought that up. So just in general, guys, if there's something that you're uncomfortable with or you need more help with, shoot me that email, write it down, say, okay, I need to email him about this. So we can make sure you're straight going forward, because everything we do is going to build upon itself. And so you don't want to have holes in your thought processes when it comes to 1.2. The next thing you know, we're in chapter 2 and you still have those holes. So we want to make sure you guys are straight. Did I see somebody in the chat? Yeah, it was a chat question. Yeah, most definitely, guys. Hey, if you see something and you're not sure where something came from, I don't know if you saw in the chat, sir, but your classmate said, thanks for asking that. But if you have a question on anything, make sure you ask, because I may be thinking about that, and I've been trying to, make sure I cover all these questions before you ask them, and I may not hit it. So if you have a question, make sure you ask it so we can make sure you guys are straight. Someone asked, when do I post, or how quickly do I post the Zoom lectures? I try to do it weekly, so I try to make sure we do, we have two classes per week. So normally by Friday, I try to go ahead and post them. But don't forget, like your classmate mentioned close to the beginning of class, these are the same notes that I did last session. So I've already given you all the lecture notes in video form, and they should be in order according to how I posted them or gave them to you. So really, excuse me, if you didn't want to wait for me to post this lecture, then you can go to that email that I sent you. And once again, they're in Canvas as well, and you can check out the video. Only reason I keep recording is because there may be a question that's asked in this class specifically that you guys may want to go reference later on. So I still want to record, our sessions, because you just never know what is said. That could be a spark for someone. All right. Okay. So it's okay. All right. Cool. So we canceled out everything. So before we go any further, everybody good? Everybody straight. Okay. All right. So we canceled out x plus 6. We canceled out x minus 2. Then we canceled out x plus 6 and x minus 2 in that last expression. That leaves us with 3 times x minus 2, 1 times x plus 6, and then 4 on the other side of the equal sign. All right. Then we can distribute. So that 3 times x and then 3 times negative 2. That'll be 3x minus 6. And then x plus 6 times 1 is just going to be x plus 6. Combine your like terms. X and 3x will be 4x. And then negative 6 and positive 6 actually cancels out for us. And that'll leave us with 4x equal to 4. And finish it off by dividing both sides by 4. And x is equal to 1. And remember, once again, with this type of problem, where you have your variable, your denominator, you at least, even if you want to plug it in and check it all the way through, you at least need to check to make sure that when you look at x equal to 1, it doesn't give you 0 in your denominators. And that doesn't happen in this case. Because, of course, 1 plus 6 is 7, 1 minus 2 is negative 1, and so on. But you do want to always at least make sure of that part. All right, questions. Let me see. I think this is, yep, these are last two. Okay. So let's look at these next two. Let me erase some stuff so we can talk about it clearly. I'll leave the blue up though. All right, so here we have 2x or 2 times x plus 1 equal to 2x plus 3. So go ahead and distribute. That'll be 2x plus 2 equal to 2x plus 3. Now we can subtract 2x from both sides. 2x is canceled. Now we have to be careful here is because with this type of problem, even though it's simpler than what we just finished talking about, a lot of times people are afraid to let math happen. And what I mean by that is that notice on the left side, 2x minus 2x cancels. But what a lot of people will do on the right side is that they will not let 2x minus 2x cancel on the right just because it looks weird. So what they would write is 2 equal to x plus 3. So, but that's not the case. If 2x minus 2x cancels on the left, then 2x minus 2x also cancels on the right. So what we're left with is 2 equal to 3 because our x variables canceled out completely. Now, this statement right here is false, right? Because of course 2 is not equal to 3. So that's when we get into what happens over here in the blue. When your variables cancel, you end up with a false statement. Your answer is no solution. So that will always be the case. If your variables cancel and you end up with a false statement. Notice Notice I didn't mention if you end up with 2 equal to 3, because if you had done this, let's say if you had decided to subtract 2 from both sides, you would have had 0 equal to 1 first. Or if you would have subtracted 3 from both sides, you would have had -1 equal to 0. Either way, both of those are false statements. So the bottom line is if your variables cancel and you end up with a false statement, then your answer is no solution. I can leave that right there. All right, questions on that one? All right, looking at the next one, we have a similar scenario. Not exactly the same, but similar. Here we have 4x plus 6 equal to 6 times x plus 1 minus 2. First thing we'll do is distribute 6. And that'll be 4x plus 6 equal to 6x plus 6 minus 2x. Combine your like terms. 6x minus 2x is equal to 4x. So notice now we have 4x plus 6 equal to 4x plus 6. Subtract 4x from both sides. Once again, variables cancel on each side, leaving us with 6 equal to 6. And this time we have a true statement. Once again, we're looking for statements. Once your variables cancel, we're looking for statements, because if you would have subtracted 6's first, then subtracted 4x, you would have had 0 equal to 0, which is still true. So when your variables cancel and you get a true statement, your answer will be all real numbers. So in the last example that gave us no solution, there's no value you can plug in for x to make it a true statement. And then for this one, no matter what you plug in for x, your answer will work out. Your statement will end up true. I think that's it. Okay. Any questions? So, with that being said, that is it for 1.2. Got 15 minutes, but we don't have to rush and jump into 1.3 today. But keep in mind, this is how we'll be, going through our lectures. Remember, you always can ask questions during the lecture. Also, remember that when we're going through these, I can't see you, especially those of you who don't have any cameras on. Well, nobody have the camera enabled. So if you're still writing, but then I decide to scroll down, I don't know that. So I do need you to communicate that with me. Some of you did. So, you say, hey, could you scroll back up or whatever the case may be? And I'll do whatever I can to accommodate you guys, but I won't know unless you let me know that you need me to either slow up, or can you pause here for a second, or you want me to re-explain something. That'll be on you guys to let me know, because once again, I can't see you. I can't even see if you're confused, by your faces or anything like that. So it's going to be, conversation between us all to make sure everybody is straight. So before we close out for today, any questions? Any questions?
Yes, sir. So we need to. So we did 1.2 today. So we're and I know we can certainly work ahead. You've stated that. So, but we need to, for the next class, we need to have 1.2 done, and be ready for 1.3. Or if we can, go ahead and move through it. Is that kind of where we're at?
Yes, that would be the best practice, to always keep up with the lectures. I understand it may not be, feasible for everybody to do that, most definitely every day. But, for those who can, I would say that's the best practice. That way, if you have questions coming into the next lecture, if we need to, if I need to address some questions first, or something like that. But if you never try the problems, then of course you won't know to ask those questions. So that would be the best practice. At some point, I will set aside a day, most definitely before the test. I will set aside a whole class day wherein all I would do is answer questions. So you guys will get that opportunity. And yeah, I mean, because if we come in the next class and someone say, hey, can we talk about a problem, then I'll try to do that before we go on to the next section. Someday I may not be able to do that every single class day, depending on how far we may get behind. But most definitely, the best way to handle the class is to at least make some attempts at the homework that we just finished discussing before we go on to the next section. All right, anybody
Now we
else?
don't need to submit that. We don't submit anything though. You'll tell us when we need to submit it all, or if we did it, you can just go in and check it. I'm not sure.
Yeah, when you go into my math lab and do it, once you hit save, it'll save your progress and give you, like, if you only done 45% of your homework, then it'll say 45.
Okay, gotcha.
Yep. So once you save that, we both get automatic feedback. You'll see what you've done.
Gotcha. So you'll see, guys. So it's not like I have to submit the assignment to anything. Once I do it in my math lab, I'm golden.
Yep.
Perfect.
Yep. Most definitely. So if you just jump into chapter 10 and start working on chapter 10 for whatever reason, I could see that. You know what I mean? Yep. All right. Anything else? Anybody else? Everybody good? All right. With that being said, you guys have a great weekend. Be safe. And I will see you. Don't forget, see you on Wednesday. See you guys on Wednesday. Have a good one.
You too. Have a good weekend.
Wednesday.
Have a great one.
Take care.
Thank you.
Thank you.
Have a good weekend. Have a great weekend.
Have a good one.
Goodbye.
Have a good one. Thank you.
And I got my my math lab to work eventually. It doesn't work on Chrome, but it works on Microsoft Internet. So
Oh, wow.
after being on the phone with tech support for an hour.
Wow. Wow. So that's the conclusion they came up with? Just use.
Yeah.
Wow. Okay. Well, at least you're in there.
Yeah. That's the important part.
Right.
But have a good weekend.
You do the same.
Hey, Professor.
Yes, sir.
I had a couple quick questions. This is Christian King. So in terms of my math lab, I believe I stated to you that I'll have a third party that is attempting to pay for my classes. They're going to be able to do it. It's just like there's a kink in the system, and I've got a case open and everything, getting figured out. I just wanted to make sure, because before I was able to access the class for my math lab, and I don't know if it's because last semester I took pre-calc with trigonometry, but that class didn't really the professor wasn't very accommodating to me because obviously I need accommodations, and he didn't really understand that I needed accommodations, so I just kind of fell behind and just took the W.
Okay.
but now it's not allowing me to access the class in my math lab. So I was wondering, I get all the way to the screen where it says select an option, use an access code, or use a credit card or PayPal to pay $75. Is that the material that I need to pay for to get into the class, or is there something that I'm doing wrong?
Yeah, that's what you need to pay for to get into the class.
Okay.
Now, but you said you have someone else that's will be paying for that for you.
Exactly. So so the reason, like, I can pay for it right now, but the thing is, I just don't know like how the payment process is going to work for the third party. I don't know if like if I pay for it now, I don't know if they'll be able to reimburse me, or if so I'm just waiting for them to actually send the money so that way I can pay for it. So that's kind of where I'm at right now. Obviously, if it's up to me, I'd already be done with 1.2 and moving on to 1.3.
So let me ask you this. Did it not give you the option for the 14-day free pass?
I looked for that. I couldn't find it. Is it on like your email or is that you sent, or is it
no,
through
it
my
should be
math lab?
it should be on that same page, but it's a small link at the bottom.
At the bottom.
Yeah.
I may have actually. Oh, there it is. Yeah, I see. I have bad vision, so I wasn't able to see that.
Yeah, no problem. Well, you got to remember they didn't make it so that you could see it. They want your
Exactly.
money.
Yeah. Exactly. Yeah. All that fine print.
Right.
So temporary access. Are you sure you want to temporarily access? So yes. All right. Cool. So it says something went wrong. Hold on. Maybe it's probably because I've been logged in for a while. I probably have to log
might have
back
kicked
in.
you out. Yeah.
Yeah. So then leading up to that, I had like two more questions. Well, obviously, I think I already answered the other one. It's, let you know that I keep getting dropped from the class just until the payment goes through. So I'm going to come in whenever I can. I have your link to the Zoom saved. So I will always be able to make the Zoom meeting. I just, the last Zoom meeting, I missed it just because I couldn't find the link. And then, it was right under my nose the whole time. So, and then in terms of factoring, I just wanted to ask you a quick question, especially with the LCD. So you take the least common denominator and you multiply it by the numerator up top all the time?
Yes, because
as well as the denominator?
Well, no, we don't want it to. We don't want to mess with the denominator. So you notice what we have here. We have x plus 6, x minus 2, and then x squared plus 4x minus 12 in our denominators. We want to cancel those out. So
yeah, and I do notice that like if you factor x squared plus 4x minus 12 down, then it gets exactly like what Matthew described. It gets x plus 6 and x minus 2.
Right. And so what we don't want is to leave any denominators there. We want to clear them out. So we don't want to multiply to the top and bottom. So we're going to multiply across the equation. So we're going to multiply to each numerator.
Understood.
That's what we did here.
I really like the way that you're teaching. Like the last professor, he just kind of breezed through everything, and the way that he taught was kind of difficult to understand, but you kind of like break it down and make it really easy, make it a lot more easy for me to understand. It comes to me pretty easily. It's just like when you have this much information coming at you at once, it's kind of overwhelming.
Right.
And I think that's really why I had to drop the last class, but this class, I definitely feel like I can succeed already.
Okay, great. That sounds good. I appreciate that.
And I did send you an email just about what I just talked about, so you don't have to respond to that.
Okay, cool. I might just say okay.
Just so that way you know.
Yeah. Okay. Thanks. Appreciate it. All
right. Well, have a great weekend. I'll see you on Wednesday.
All right. Sounds good. You do the same.
Yes, sir.
All right. Civils, did you have a question as well? All right. Going once, going twice. All right. You have a good weekend. Take care.